right, good morning everyone. I know you must be tired and might be a little bit hungry right now, so I'm going to make this session very short. So in this TA session, I'm going to explain detail about the Harrod&Domer model, mainly focusing on the mathematical derivation. And this TA session is designed mainly for the students who have little knowledge in mathematical notation as how it is related to economic analysis. As you might know, in modern economics, mathematics has become the inevitable tool, and you need to be very sensitive to the mathematical notations. For example, the capital letter, the lowercase letter, and the superscript, etc. You have to be very sensitive. So of course, if you are familiar with the Harrod&Domer model or the Solow model, and you are comfortable with the mathematical notation expressed in the lecture notes, there is really no need for you to sit here, and you can choose to leave anytime you want. All right, is that clear? Okay, let's get started. So in this session, I'm going to talk about 5 parts. So the background of Harrod&Domer model, how we set up the model, and 2 forms we have already discussed in the lecture, and finally the conclusion part. So firstly, it's the model developed by 2 economists, Harrod and Domer, in 1930s. Actually, Harrod was a close friend of John Keynes, and this model was developed heavily on the work developed by John Keynes. It also developed the short-term Keynes economic growth theory into a long-term economic growth theory. One of the most important findings of this model is that it indicates that the capital accumulation is the major driving force of the economic growth for the whole nation. We'll see that later. Okay, about the setup of the model. When you see all these alphabets, you don't have to panic. Actually, there's an easy way to remember these alphabets. There are only 2 groups of alphabets in this model. The first group is called the core elements of the model, or the endogenous variables, which change over time. There are only 3 letters which are used, 3 elements used in this model. The first 3 capital letter. K, L, and Y, capital stock, working force, and production, or the national income. The 4th and the 5th, the small letter, the K and the Y, are just derived based on the first 3. So the most importantly, just to remember the first 3. And K and L, we assume they are the only inputs to produce the national income in this model. The second group of the model is called, the second group of the alphabets is called the parameters, which stay constant over time. Actually, there are also 3 parameters in this model. The small letter, the S, saving rate, they're defined by S over Y, delta, the depreciation rate of capital K, and theta, the capital output ratio, defined by K, capital letter K over Y. T is just the indication of the time of the production. And also, I can give you an example to remember these 2 groups of alphabets. For example, if you drive a car, the endogenous variables are just like the engine of the car. They determine the fundamental performance of the car. They're most important. And the parameters, just like the minor parts of the car, like the wheels, the speed meters, they change the direction or the speed of the car, but they cannot decide the fundamental function of the car. So that's just to give you an image to remember that. Okay, so how do we set up the model? After we know the parameters, then we need to make assumptions to construct the model. So firstly, we assume that the national income Y is divided into 2 parts, consumption consumption and savings. So that's the first equation we get. Furthermore, we assume that the economy we are considering is a closed economy. That means there is no trade or capital flow going on in between countries. So that means all the savings will be used for investment. On the other hand, investment will only comes from the savings from all the households. So that's the second equation we get. And thirdly, we further assume that the constant fraction of the income will be saved. So we get the small letter, the lowercase s, it's the saving rate, equals the capital letter S over Y. All right. After setting up the model, then we move on to the model while we ignore the population growth. Since we have mentioned previously, there are only two inputs in this model, the capital accumulation and capital stock and labor force. But there is no population growth here, so we only have to focus on the dynamics of capital stock in this case. So what's the relationship between the capital letter K at time t plus 1 and the K at time t? As Professor Osodowski has mentioned in the class, the equation 4 is very important. And it's also easy to remember this. We can think it in this way. The increase, the accumulation of the capital actually comes from two parts. In the first hand, it inherits the capital stock from the previous period. So as capital also wears out over time, for example, if you buy a machine, it loses value over time. And also the land of the factory, it loses value as well. So at time t plus 1, you only, the capital which is left is only 1 minus delta times kt. The other source of the capital accumulation comes from investment. So all the investment will contribute to the new increase of part of the capital stock. So we plug second equation in. What's the second one? So we assume the S equals I, investment. So we plus this equation in, and we get equation 5. And we already defined K equals theta times yt, and SD is equals S over yt. So we plug all them in, and we get the 7th equation. And this one is very important because it tells us the relationship between the national income at time t plus 1 and income at time t. So later we're going to use this to derive the growth rate of the national income. So furthermore, we assume there is no population growth, which means LT plus 1 equals LT. And we also define the small capital, the lowercase to YT, output per worker equals YT over LT. And we divide both sides of equation 7 by LT first. And then we divide So we first divide both sides of 7 by LT, and then we divide them by theta YT, and we get the equation of 8. So this is the relation to show, this shows the relation between the national income, the income per worker at time t plus 1 and that at time t. Okay. So our final purpose is to find